Hello everybody. Today we're doing Leet Code 238, product of array except self. Given an integer array nums, return an array answer such that answer sub I is equal to the product of all the elements of nums except nums sub I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operator. So let's look at example 1. In example 1, nums is 1, 2, 3, 4, and our output is 24, 12, 8, and 6. Because if we look at position 0, we take out 1, and we multiply 2 times 3 times 4, that equals to 24. And that goes right here. At the next position, position 1, if we take out this number 2, when we multiply these three numbers together, 4, 3, and 1, we get 12, and that goes right here. And for the second position, if we take out 3, we multiply 1, 2, and 4, we get 8. We'll stick this right here. And for the very last one, if we take out the third position and we multiply 1, 2, and 3, we get 6. And that is our very last one. So the fun part of this problem is that they give you a couple of constraints. One is that you have to run it in O of n time and without using the division operation. Because if you were to divide, it's very easy. You would multiply the entire array. 1 times 2 times 3 times 4 equals 24. And in this position, 24 divided by 1 would equal to 24. 24 divided by 2 would equal to 12. And 24 divided by 3 is equal to 8. And 24 divided by 4 is equal to 6. So one way to go about this problem is the idea of using prefix and postfix, which are just arrays in this sense. So for your nums array, you have 1, 2, 3, 4. And then for your prefix and your postfix, it'll have the same amount of space for both. And what we want to do is, so for number 1, we want to find all the numbers before it, which is nothing here. So in this case, it'll be 1. And all the numbers after it, which is 2, 3, 4, multiply all of these prefix and postfix together in order to get to 24. So for example, if you want number 2 and you want to find what this output should be, we want to find all the numbers on the left side, your prefix, and all the numbers on the right side, and multiply them together. So 1, 3, and 4 is going to equal to 12, and that would be your answer here, 12. So to get the numbers for your prefix array, we'll start with a variable and have that equal to 1. Because if we look at this current number 1, there's nothing to the left of it, but we need something to the left of it in order to find a prefix. So for this very first place, we want to find everything to the left of this 1. And because there's nothing to the left of it, we're going to have it assigned to 1. Because 1 times 1 will equal to 1. And now for this value, we want everything to the left of it, which is 1 times 1 will also equal to 1. For this position, everything to the left of it, 2 times 1 is equal to 2. Here we'll have 2. And in this position, everything to the left is equal to 6. So here we'll have 6. Now for a postfix, it's the same idea. We want all the numbers to the right. So if we look at number 4, everything to the right side of it, if there's nothing here, we're going to have it equal to 1. So in this position, we'll put a 1. For number 3, everything to the right of it is 4 times this 1. So in this position, we'll have a 4. For this one, everything to the right of it is 3 times 4 times this imaginary 1, which is equal to 12. So we'll have 12 right here. And for this one, we'll have everything to the right of it, 2 times 3 times 4, which is equal to 24. 24 right here. So in order to find what to put into the corresponding indices for answer, we are simply going to multiply these two. So the prefix by the postfix. So 1 times 24 is 24. 1 times 12 is 12. 2 times 4 is 8. And 6 times 1 is 6. And that is your output answer. So for time, we have to iterate through every single element for the input. We will call this as O of n for time. And for space, because we're creating two arrays of the same size as nums in terms of how many elements there are in it, space will also be O of n. And the follow-up question asks if we can compute this in O of 1 time, where the array for answer does not take up extra space. And we can do that by using the array for answer itself, as well as using this idea of prefix and postfix within the array answer. So we get rid of entirely of all of this because we're not using it at all. And all we need to use is the final array for our prefix. So for our answer array, we'll be reading nums and inputting prefix going forward. And then for our postfix, we'll be modifying the answers and then putting it in backwards to get our final result. So what that would look like is we're going to start with a variable called prefix, and we're going to assign it the number 1. As we go through it forward to do our prefix, we are going to input our prefix into this array. So in order to do the prefix and postfix in here, we're going to input prefix going forward, and then we'll modify it and put postfix going backwards so that at the end we can return our answer array. What we want to do is create a variable called prefix, which will store our prefix at any given time that we're going to use to multiply as we go through this answer array. So at the very first iteration, when I is equal to 0, what we want to do is take prefix and put it into our answer. So it'll be equal to 1. And then we're going to update prefix by taking num sub I times 1, which is equal to 1, so it'll stay 1. At the next iteration, when I is at 2, we're going to take prefix, put it into answer. We're going to update prefix by taking 2 times 1, which is equal to 2. Then at the next iteration, when I is at 3, we want to, when I say at 3, I mean the value 3. At the current iteration, this would be at 2. So what we would want to do is take prefix 2 and put it into our box down here and update prefix by taking 3 times 2, which is equal to 6. And then for the next iteration, when I is currently at 3, which is at this number 4, at the next iteration, when I is equal to 3 and our value is at 4, what we want to do is put 6 into our answer, and we want to update prefix by doing 4 times 26, which is equal to 24. So prefix is equal to 24, but we don't do anything with this number because we've run out of space in our array. Now to do our postfix, we are going to read and modify this array going backwards. So we'll have I is equal to 0. Before we even start the for loop, we'll make sure that we have a postfix variable, which is equal to 1. So when I is currently at this location, what we want to do is take number 6 times postfix, which is 1, and leave it as 6. Then we want to update postfix by taking 4 times 1, which is equal to 4. And then we're going to decrement it by 1. So now I is at this location, and we want to take 4 times 2, which is equal to 8. And we also want to update postfix by taking 4 and 3 and multiply it by each other. So this is now 12. We decrement it by 1. At this location, we take 12 and we multiply it by 1. So now this is equal to 12. And we want to update 12 by doing 2 times 12, which is 24. We decrement this by 1. So now at this location, we are going to take 24 or postfix, multiply it by 1, which is 24, and update our postfix by taking 1 times 24, which is equal to 24, and that is the very end of our loop. And at the very end, we return answer, which is 24, 12, 8, and 6. So for the time and space complexity for this, because we're going through every single element, it is still O of n. But now we don't create any extra arrays or store anything extra besides using this answer array. And it was given to us that using this answer array doesn't take up extra space. So for time, it is O of n. And for space, it is O of 1. Now let's see what it looked like in the code. All right, so first we are going to create our resulting array, which is const answer equals new, which is the same size as our nums input array. And I'm just going to fill it up with 0. Technically, you can just have it as this and it'll work, but I want to be explicit about it and have it fill up with 0. So first we're going to create our prefix. The prefix equals 1, and then we're going to go through our array going forwards and input those prefix numbers. So for let I equals 0, let I is less than nums.length, I plus plus. And what we want to do is answer sub I for that location. It's going to equal to answer sub I times prefix. And we want to update our prefix as well. So that will be prefix equals prefix times nums sub I. Now, when that is done, our prefix numbers are all set in there. We want to do postfix by going backwards. So we're going to have postfix equal to 1 and iterate backwards by let I equals nums.length minus 1, and I is greater than or equal to 0, I minus. So here, what we want to do is answer sub I equals to answer sub I times our postfix, and we want to update our postfix as well. So postfix times nums sub. At the very end, we're returning our answer. So let's go ahead and see if this passes our test cases. And it doesn't because, oh, here's the tricky part. This is not what we want. We want our answer sub I to equal to just prefix. Let's try this one more time. And that also doesn't work. What do we got going on here? Okay, let's debug this together. Answer sub I equals answer sub I times postfix. Awesome. Oh, we have a little typo here. Let's run this. It passes our test cases. And let's see, one thing, we can refactor this code a little bit to have it look like this. So it's a little bit more succinct, which is essentially saying that answer sub I is equal to prefix, and then prefix is equal to prefix times num sub I. And for line 16, it's answer sub I equals to answer sub I times postfix, and postfix equals to postfix times num sub I. So let's run this, and it passes. So there you have it. So if you enjoyed this video and would like to see more, please help out by liking and subscribing. Appreciate your time. Thanks for viewing. Hope to see y'all soon. Bye.